Okay, so let's look at some examples from the practice for chi-squared. Um, we basically will always be given three things. A teacher's explaining to her class the concepts of genetics regarding eye color. She assumes that each category will have the same number of students in it. So that's important. We need to know that we'll have the same number of students in each of the categories. We also need to know what the categories are. The category is observed eye colors, and there are blue, green, brown, and hazel eyes. And then the third thing we need to know, well, that is the third thing we need to know, is the count. So we need the category is the color of eye, the counts, can't get that there. The counts we'll put in another column, and the number of students are going to be the same in each category. So I come over here and I put in category, which is eye color. And then maybe in the next column, I want to put the counts. And this is the observed counts. And then in the third column, we are going to put the proportion, or we can choose to leave that blank. We might leave it blank because it's equal proportions, because it says the same number of students. So we can leave it blank, and Minitab will fill that in if it says the same number of students in each category. That means the same proportion for each category. So let's put in our colors. We have blue, green, so that's our category column, brown, and hazel. Okay, and then let's put in our counts that were observed for each of those. 3 had blue eyes, 2 had green, 12 had brown, and 3 had hazel. And the proportions, since there's only 4, we could put that in. But if all the proportions are the same and there are 4 things, it would be 0.25, 0.25, 0.25, and 0.25. But if they're the same, we don't have to put those in. So I'm not even going to put anything in that column, and I'll show you why in a second. All right, so now we want to see if we can answer these questions here. Let's go ahead and start answering the questions. What are the observed for the green eyes? For blue eyes, that's 3, it tells us. For the green eyes, 2 were observed. For the brown, 12 people had brown and 3 had hazel. What are the expected values for the blue eye color? So hold off right there on the expected, because Minitab will give us that. So let's go run it. You go stat, go down to tables, and we're running a chi-squared good as the fit test. The observed counts are in column 2. The category names are in column C1, and we want equal portions. So if this isn't already on equal portions, if you'll click that, and then that's everything we need. So in this one, we really just need the 2 things, because the third column would be proportions, and those are equal. So click OK and pull this down so we can see what we got here. And this is what we have. Now we can see the observed count for the blue eyes is 3, and the expected is 5. They're all expected to have 5 because there are 20 total. And if they're all going to be the same, then it would be 5, 5, 5, and 5. Okay, what are the degrees of freedom? So come down here. Degrees of freedom is our number of groups minus 1, and Minitab tells us that the degrees of freedom is 3. We also know, even though it doesn't ask for it, that the number of eye colors that we counted total was 20, and we could have found that by adding 3 plus 2 plus 12 plus 3 as well, but we don't have to do that because Minitab does. It says, what is the null hypothesis? Remember, the null hypothesis is always the equal part, so we're choosing the distribution of the eye colors is all the same. They're all equal. The alternative hypothesis is the opposite, so we would say that the distribution of the eye colors is not the same. What is the test statistic? You get that from right here. It's the chi-squared test statistic. It's 13.2. And what is your p-value? Rounded to 3 decimal places, it's 0.004. What is your conclusion based on the p-value and the level of significance? Okay, they told us up above that the level of significance, I believe, 0.05. So that is where we use our people eat fish from the river Nile. So if P is less than or equal to 0.05, and I like to put in the extra 0 there, then we are going to reject my null. So 4 is less than or equal to 50. So we are rejecting the null hypothesis, and we conclude the alternate hypothesis then, which is at the 5% level of significance, the distribution of the eye colors is not the same. Okay, now let's look through that same problem kind of again in a different light. It's very similar. Actually, is it the same? A teacher's explaining to her class the concepts of genetics regarding eye color. She assumes that the categories, so everything's the same, 0.05 level of significance. She said the observed were the same, but this time the categories are going to have these proportions. So this time we're actually going to have that proportions calendar. Column. So I'm coming over here, make sure I've got blue is 3, green is 2, brown is 12, hazel is 3, and this time we want to put in our proportions. Remember, proportions are always the decimal part of that percent. So the first one is 0.20. The green is 0.10 for 10%. The brown proportion for people that have brown eyes are 0.50 or 50%, and the percent hazel is 20% or 0.2. So put those in, and now we're going to run it again. Let me see. I thought the rest of the questions were on here, so we're going to run through the same questions. So let me just see if I can't get a blank page here. File. Can I do new? No, let's do. I can only open, huh? I can't do a file new. Let's try over here. File. No, looks like I can only open ones. Let me see if I can open. Nope. File. Okay, so I will come right back. So let's answer our questions again. What are our observed values? So how many people had blue eye color that we counted? And that is 3. So 3. How many had green? It's observed. 2 people had it. We observed them. 12 people had brown eye color that we observed, and 3 had hazel. What are our expected values? We need to put it in Minitab so we can get our expected values. We could actually compute those by hand, but we'll just let Minitab do it for us. Our expected values are what the proportions are given us. Now, I already put the proportions in here. So now we just go to Stat, Tables, chi-square goodness of fit. The observed counts are still under observed. The category name is still category of eye color. And our proportion is in a column. And that column is the input column with specific proportions is the one I named proportion. So you have to put your cursor here before it will, y'all saw that it would, you have to put the cursor there before it lets me choose something. Or we could have actually put them in ourselves, but we've already got them in a column here, so we didn't need to. So click OK, and then we get our answers. The expected values for the blue eye color, there were 3 that we observed. We expected to have 4. Okay, for the green eye color, we expected 2 because that is 10%, because our test proportion was 10% of the 20, which would be 2. Half of them we expected to be brown. Half of the 20 is 10, but like I said, Minitab did that for us. And the expected value for the hazel eye color, we observed 3, but we expected there to be 4 because 4 is 20% of the total number of students, which was 20. Okay, so 4. What are the degrees of freedom? Again, that's 4 minus 1, which is 3. It's always your groups minus 1. What is the null hypothesis? Again, pick the one that means that they're the same or they're equivalent. The equal sign goes on top, so that's the null hypothesis. And then the alternate hypothesis is the opposite, which is that they are not the same. What is our test statistic? Test statistic is our chi-squared number here. My chi-squared test statistic and my p-value is 0.825. So now I need to make a conclusion based on the p-value. If p is less than or equal to the significance level, then we will reject our null hypothesis. P is 0.825, and we're checking that against our significance level, which didn't change, and it told us that at the beginning of the problem, that use a 0.05 level of significance. So we're looking at 825, and we want to know if that is less than 50. 825 is not less than or equal to 50, so we're not rejecting the null hypothesis, which means we're keeping it. So if I'm not rejecting the hypothesis, then I'm keeping it, and the keeping it, you're failing to reject the null hypothesis. We're not rejecting it, we're failing to reject it. Okay, and then that means that our answer is coming from the null hypothesis, which was that they are the same. So we failed to reject the null hypothesis because 825 is not less than or equal to 50. 825 is so we're not rejecting, or we're failing to reject is how we word it, failing to reject HO. If we don't reject HO, we keep HO, and HO, which is the null hypothesis, is that the distribution for each eye color of those proportions that they gave us are actually the same. So you're going to choose the distribution of the eye colors is the same. Let's look at that over here, and we'll see on this chart that the blue, which is the observed, and the orange, which is the expected, you can see that they're very close to one another. So they did, basically they do come out similar to the same. So I hope that helps, and you can pause this as needed.